My name's Yair. My company's SmartLogic. We build custom web and mobile applications that run on the internet. Today I'm going to talk about how the internet works and then share some ideas for how to use the internet. Go ahead. So that's my intro slide. Sorry, I thought that was going to be my intro slide. So anyway, we know that the internet has had a profound impact on society since its inception in 1969, which is also the year that Catherine Robinson was born. So the internet says that there are about 3 billion internet users today that are connected to the internet via approximately 9 billion devices, such as your iPhone, your iPad, a Nokia phone, your laptop, so on and so forth. 9 billion is a large number, but let's put that in perspective. There are 12 billion light bulbs, 7 billion humans, 1.5 billion cats and dogs, about 1.1 billion cars, and just under 900 million civilian-owned guns, a third of which are owned here in the USA. So let's drop down and figure out how data actually moved from point A to point B on the internet. The first thing we have to understand is that every image or movie you download is split up into little packets of data. A movie, a 700 megabyte movie, might translate into 1.3 million packets of data. So let's use the USPS as a metaphor to try to explain how data physically moves from point A to point B. So when you send a letter, you're using all these different transportation mechanisms. You drop it in a post box, then it goes to a truck, then it goes to a conveyor belt in the post office, then back to a truck, and then to your final recipient. Similarly, with the internet, when you transfer these data packets, it might go from your cell phone to a cell tower over airwaves, and it might go to a data center somewhere via Ethernet, makes a pit stop at the NSA, to Comcast, 802.11 to your home, so on and so forth. So that's how data move. Then above that, we have the internet layer. And the internet layer doesn't care how data physically move from point A to point B. It just gives you the best route from point A to Z through B, C, D, so on and so forth. Above that, we have the transport layer. And the transport layer confirms and verifies that the receiver receives the data that you send and in the correct order so that your data don't look all jumbled up like the picture in the bottom right. Then above the transport layer, we have the application layer, and that's what is most familiar to us humans. So the USPS, they don't care what you're sending in packages. Similarly, we don't care how they transfer the packages. So all we care about is that the steaks, the shoes, the booze, so on and so forth get to our doorstep. Similarly with the internet doesn't care what data we send through it, and we don't care how it works. All we want to know is that when we use HTTP or HTTPS to load a web page, that it's going to work. And we want SMTP and POP3 and IMAP, and we want that stuff to work for email. So that's how the internet works. It's pretty simple. Let's think about what's next. So when we think about what's next, we have to consider the fact that there are companies like Google, Amazon, Microsoft that all have 1 or 2 million servers. So computing power is a complete commodity. It's very cheap. What that means is that we can put the internet on all these things. You might have a thermostat connected to the internet, a pigeon connected to the internet, cars connected to the internet, and they do all this stuff. That was supposed to be from Twister, the movie, but in any case. So what if we had internet-connected plastic bottles? And this speaks to the trash problem from before. What that would allow us to do is track a 20-ounce bottle that goes from the warehouse all the way through the supply chain that gets bought in some convenience store in some neighborhood in Baltimore, and then we could track whether it ends up in a landfill or whether it ends up in the inner harbor. And what we could do, if we measure all those data points, we could see whether there's a given neighborhood in Baltimore that has a disproportionate amount of litter, and then we could devote more resources to that neighborhood, more trash cans, more litter people, education, so on and so forth. What if we had internet-connected ammunition? I'm not talking about a $1.5 million Tomahawk missile. I'm talking about a $30,000 mortar that you find in certain parts of the world, or a $2 bullet. So what that would allow us to do is track where the bullet lands or where the mortar lands relative to where we expected it to land. So this guy might shoot a mortar. He might place a call on his iPad, "Hi, Mom." He might play some words with friends, figure out where the mortar landed, and then adjust the weaponry so that he can send another mortar closer to the target. So you all have heard of Fitbit. What about Shipbit? So if we had an internet-connected device in our toilets that was measuring, small samples of our urine or feces, so on and so forth, and sent that data back for processing to some server somewhere, we could determine things like, you see that red outburst over there? That's herpes. We got to watch out. On an individual level, we could say that, hey, your cholesterol is increasing. You got to change your diet, so on and so forth. The last idea, what if we had internet-connected traffic lights? So the traffic lights, they're pretty stupid as it is. They just go from green to yellow to red on a certain schedule. Sometimes there's a little sensor on the ground at the intersection, but if those traffic lights could talk to each other, then we could do things like reduce emissions and increase productivity by determining that there's no traffic going north or southbound, so let's let east and westbound stay green for a little bit longer so that we can get people to work or their destinations faster, and again, cut down on emissions. Thanks.